All right. Lightning Talks. So this is the developer conference. Lightning Talks are one of my favorite things that happen at a lot of developer conferences. It gives you a chance to sample the breadth of the 3,000 to 4,000 ROS packages that are out there in a very concise ADD. We're going to be drinking beer after this format. So we'll try and breeze through this. People giving lightning talks, you'll see your name in the bottom right. If you're on deck, it'll say next, your name, so get up here as quickly as you can so we can keep breezing through this. And remember, you have 3 minutes. We're going to hard cut you off because, again, beer. So to give a lightning talk by demonstration, what does ROS Awesome do? This is probably the most frequently asked question I get in person when someone comes to lunch at Willow Garage. So that's RTFS. It's very easy. ROS Awesome is kind of a historical hat tip to the many names that Morgan inflicted on ROS. So you can see that it basically reintroduces those original names. We have Mega Maid and Suck to Blow, which are good old Spaceballs references. My favorite was actually not by Morgan, but one of our interns, Alex Teachman, who did Dustbuster. It recorded one message. And that last one is Bot Herder, not Both-herder or Botherder. But we took all these out of the system because in the end, conventions are good. They let you learn the system more quickly. So a good convention that we decided on is anything dealing with ROS is ROS and then the name of the concept. So Mega Maid was bad. ROS Play also was bad because play wasn't the concept, bag was the concept. So we renamed it to ROS Bag to keep it nice and simple. Of course, oops, we have some deprecated code in our source because we're using the deprecated aliases, but that's okay. And as a final question, I'll let you decide if ROS WTF is good or bad by this convention, but as Damon Kohler was telling me, it may not be ROS Awesome, but it's definitely ROSome.
ROS Industrial, it's a status update. A lot of people mentioned it in their talks today, so I'm not going to go into a lot of detail. But what we're doing is leveraging ROS for the factory floor. We're starting with ARMS, but we have other applications that have nothing to do with ARMS that ROS can help us with. Supported hardware, that means we have visualizations, URDFs, and various levels of support for them. Motoman, Adept, ABB, those are all industrial manipulators. EtherCAT via the simple open EtherCAT master library, and more to come. We're talking to lots of people about this. Development is continuing. We have a Freetail project at Swiri. Look in the repository if you're curious. And Motoman is working on faster interfaces and more robots. Special thanks to Willow Garage, Southwest Research, and Motoman. We're going to start a consortium, fourth quarter 2012 or first quarter 13. And we're looking for developers who are interested in this and interested in helping us. There we go. And there are some links, lots of information if you want to look us up on the web. And one last thing, ROS Enterprise, which is a SIG that's kind of forming that we're very interested in, is going to meet at 6 o'clock in the ballroom, and we're going to meet on this side of the ballroom so that we can all get together for dinner, it sounds like. All right.
There we go. Hi, I'm Chad Jenkins. I'm Associate Professor of Computer Science at Brown University, who's always looking for great students, postdocs, and collaborators. And as an example of what I do with my students and postdocs and collaborators is I just want to show a quick video of a hackathon we had earlier this year. Thank you.
I can't believe I had to follow that, and they don't even have funky music. And you're going to show me how to do it this summer. I'm Steve Cousins from Willow Garage, and I got asked the question, what is the OSRF, and why did you guys spin it out? And so I thought I would just take 2 minutes to answer that or so. So Open Source Robotics Foundation, you notice if you take off the foundation part is OSRF, and there's an interesting permutation of ROS off. It turns out there's a guy named Ross with ROS last name. He died. His family has a foundation. We can't have that name. So we have the Open Source Robotics Foundation, which is nice because it's more general and also lets us include things like Gazebo and other open source robotics packages. The foundation exists because we want a central place where different organizations, entities can contribute money that's not Willow Garage. Why not Willow Garage? Well, we make robots. Other companies make robots. If we're owning the software, even if it's BSD, it feels to everybody like, well, we shouldn't give you money to support that, right? But I want ROS to be a community effort. It is already a community effort, but I want people to realize that. And if you look back in history, there's ROS.org, right? Why is there ROS.org? First of all, it's shorter than willowgarage.com, but more importantly, it ends in .org, right? And so when we created ROS.org, we created ROS, we said this is BSD, this is open to the community, it's a community effort. Willow Garage contributes to it, but everybody else can contribute to it too. And we've been looking for the last 2 years for an opportunity to create this foundation, this central position. And what we were looking for really was funding. And so recently DARPA has the Robotics Challenge. They were looking for someone to do the simulator, and so we said this is a great opportunity, this is a great match. So DARPA's putting a big chunk of money in to improve Gazebo, and so the Gazebo team and Brian have gone off to create OSRF, and we have now one more player in the ROS community, more importantly, a player that will support the long-term health and ability of ROS. So Willow Garage continues to be interested in ROS. We'll continue to have developers working on ROS. You notice the ROS team and the people that are speaking, most of them will continue to work for Willow Garage. But we now have another player in town who's also supporting it, which we think is just fantastic. So I want to say one more thing, which is how am I doing? 45 seconds, excellent. One more thing, which is, I was watching the Willow Garage talks this morning, and somebody said third party, right? Like, here's our packages, and here's third-party packages, which I want to publicly correct for everyone. ROS is for all of us. There is no third party, or we're all third parties, right? There's no center, and this move, this creating the Open Source Robotics Foundation, just makes that a little bit more obvious, right? We all contribute to it, we all use what's there, and from any given institution's point of view, maybe everything else is third party, but for all of us, it's all one big happy community. So welcome to the ROS community. I'm glad you're all here. It's a fantastic event. Thanks, Brian.
Minutes. Okay, so I'm Jonathan Claessens. I'm from South Africa, CSR. We do a lot of work with the mining industry. So one of the things we do is we want to put an operator of a vehicle on the surface and take his job and put a machine there to do it for him. One of the issues is that with someone who's used to doing it himself, he needs a very simple software interface, very simple. So we can't really put RViz in front of him with topics. And so what we're doing at the moment is working toward a customizable version of RViz. So just to advertise it, basically the first starting point for us was to basically take some sections of RViz as well and make a customizable version of just RViz. And then from there, the idea is to take it to a point where it's a very, very easy interface. So at the moment we have just basically use your standard markers. I've also added some, so you can support now with CRI, it supports the standard messages, so your point clouds, your grid maps, that sort of thing. And I've added support for the URDF format as well, although it's a separate program that you run and it imports it as markers. So the menu system in the thing and most of the sort of housekeeping stuff is all Python. You can rewrite that very easily. I've added also, I say completely scriptable in PyQt, not true actually. It's completely scriptable in Python. So the example here is in the technology test of the software. If you click on a bubble, it explodes because there's a script So there's a node that sends a script, Python script, to the visualizer, so of course CRI, and it tells it to publish a message to the program, and the program tells then CRI to destroy the bubble. So there's a scripting element to it that we've added as well. And I've started working on being able to specify chains through a variant of the interactive marker. So you can actually now also specify TF chains as well as complicated sort of goals. Or if you want to, for instance, I'm working on this at the moment, that you can, for instance, take an object. If you want it to be in a certain place on the table, you pick underneath the object a certain point, you pick where you want it on the table, and you can mate the two. So basically, that's the lowdown. The roadmap is really to do what I said earlier, is to make a very simple version of Arvis that someone just off the street can use, completely off the street. And of course, also to then grow it into an IDE so that you can make your interface very quickly and hack it if you need to. But that's it.
Hello, my name is Jonathan Bourne, and I'm a graduate student. So this means, of course, that the goal over the course of the next few years is for me to do science. But in addition to doing science, I'm also going to be writing a lot of software, and I have written a lot of software. And I think a lot of people have noticed the wild code that Morgan referred to this morning, and a lot of that wild code is written by graduate students. And I think that a lot of graduate students actually don't have a lot of experience in doing software development or doing releases or maintaining code. And I think there's a potential for the Open Source Robotics Foundation to help us with this. And what I'm proposing is something along the lines of Open Source Robotics Foundation student chapters at universities, organizations, to either guide or set up protocols or basically enable us to better create code that others can use, as opposed to this sort of half-working jumble of stuff that might have been in a project once and isn't maintained anymore. And I think it could really benefit the community, and as well as set up sort of, a situation where we're not just publishing academic papers, but we're also publishing the code that goes into those papers so that others can reproduce our experiments. And I think there's a lot of potential here to really sort of take advantage of this whole community and the sort of new paradigms in how robotics research is done. That's it. And there's a birds of a feather thing. I'm not quite sure when it's going to happen, but just meet up with me probably after the banquet and we'll figure it out. Or the reception, the NREC reception.
Hit left and right. Okay, I'm Bob Dean. I'm from General Dynamics Robotic Systems. We're one of the hard real-time companies that was mentioned a couple times earlier today. Our specialty is in what's called supervised autonomy. We've done high-speed on-road, off-road stuff for a very long time. As part of that, we've traditionally made our own LiDARs because it's a great sensing system. So what I'm here to talk about is we have something called a micro LiDAR. There we go, page down. It's smaller than a soda can. Which basically gives a 3D depth range grayed out, just like traditional LiDARs do. If you've used a Velodyne, then you know the type of data to expect. And the neat thing about this is that, this is about 1/10 of a second worth of data. It looks kind of what you get out of a standard LiDAR. Our LiDAR does a phase shift with a multi-return. So what that means is that there will be no gaps in your data, like you do with traditional LiDARs, where you'll have your scan lines and then an angular difference, which increases with range. So we can see here this was taken in someone's office. So that's a picture of some curtains in a cabinet. And the neat thing about the cabinet is you can see the seam of the door that goes up the left-hand side, which I've been doing this for many, many years. I've never seen a LiDAR that could actually do something like that. The colors in here are actually intensity. So we do give intensity out with our data. This is a picture of our test area. So this is just to show you we have a longer range. In the center there, there's some test targets with also showing intensity. And right now, we're getting range greater than 60 meters. That's the number I'm allowed to say. And this should be on the market in a couple weeks. In production yields, we're looking at something substantially cheaper than Velodyne 32E. Runs about 20 watts. And that's that.
Hey, I'm Brandon Alexander. I've been trying to get web developers into ROS, basically make ROS more accessible to web developers. And I'll quickly list 4 tools that I found help with that. The first one is ROS.js. It's a JavaScript library that lets you interact with ROS in the browser. That's all I'm going to go into it because there's a big talk on it tomorrow. The next one, though, is a client library, a JavaScript client library that was recently released called ROS.Node.js. And you can get to it by Googling. But that actually lets you write JavaScript that will match the similar ROS.js API in the browser. And so you can actually use JavaScript on the robot directly with no browser. The third one is deployment scripts. So a lot of web developers, they can deploy a whole server with one script using things like Chef and other and Vagrant and other deployment tools. So I'm trying to get some of those tools to integrate with ROS. So if you actually go to my GitHub address now, I have a script that uses Chef and Vagrant, so you can create a whole ROS environment from scratch in one line. I'm hoping to see more of that involvement in the future, so we can kind of like work together with things like Chef, Puppet, Vagrant for ROS, so you can quickly set up an environment. And fourth one, GitHub. I think a lot of people should use it more. I know that's a little controversial, but as an example, when I released ROS.Node.js, within 4 hours, without announcing it to anybody, I had someone fork the project and start making changes. So I just think it opens up the code, makes it a lot more accessible to web developers and other people out there. Thanks.
Good evening. Welcome to the PH-Spline Trajectory Planner Stack. My name is Ganesh Kumar. I work with my advisor, Dr. Shrikant Saripalli at the Astral Lab of Arizona State University. And this is probably one of the wild code modules that were mentioned earlier today by Morgan Quigley. So you never know when it is going to hit you when you use it. A PH-Spline is an abbreviation for a really long term. Never mind what exactly it is. And it's a variation of a spline that was recently developed to interpolate smoothly between waypoints on a robotic trajectory. They have a number of cool, elegant mathematical properties, including the fact that their arc length can be evaluated purely analytically. And you can see a PH-Spline here, displayed here. It's a MATLAB plot. So we wrote a PH-Spline-based trajectory planner. Our design is very simple. We use MoveBase. For the base local planner, we ripped off the goal parser from the navigation experimental stack, and we substituted a PH-Spline goal parser. And similarly, we had a PH-Spline post follower, following the simple post follower. And we have an auxiliary package known as PH-Spline generator that plugs into the goal parser. The generator talks to MATLAB. So this part, the PH-Spline generator and MATLAB, forms the heart of our code. So there are a number of configuration params which enable you to tweak the splines in such a way that they really suit you. For example, you can evade the loops, or you can use control points instead of waypoints, and so forth. So here is one simple PH-Spline. All I'll say right now is that you can see that the spline on the right is much smoother than the path on the left, which is one of the main uses. So in future, I hope to maintain it. I have a few years of software development experience, luckily. So I hope to maintain it in such a way that you all get to use it extremely well. And I plan to use the ROS MATLAB IPC bridge instead of the file-based communication we have here. And we are also ambitious enough to make this work on the Hector quadrotor stack. And you can see a video. Unfortunately, it's a little bit too dark. I can't understand why. It's not meant to hit you or anything, but this was meant to, you can see a rover.
Right.
Yeah,
Sorry.
yeah, thank you.
This one is also.
Hello, my name is Marek Sadowski. I come from Poland. My company, I founded 2004, is doing small robots, and now we are entering ROS. You can see the team of 5 doing Oling, and you see CEO, you see service director, ROS architect who is here with me. You have cache source, and chief constructor and assistant constructor. Now we are moving, I would like to show you where we are, and B, where we are going tomorrow. And now we have entered the project of a fleet or swarm of robots. We are going to use ROS to develop it. And if you see somebody calling from Robotics Inventions, please remember that I was standing here and asking you for help. So I'm asking you for help if something goes wrong. We are Bangalore for robotics. If you need some outsourcing, you can talk to us, and maybe you can come over to you and help you. Otherwise, please remember that maybe next year we'll come over here with several robots that are working and cooperating together. Thank you.
Hi, my name's Paul Bouchier from the Dallas Personal Robotics Group. We've got a group down there that are very excited about ROS. I'm a hobbyist, and there's a class of robot controllers that was not addressed in Morgan's talk this morning, smaller than Smallbot, but bigger than what he called Microbot. I've got an example of one here, but there's several things like Chumby, things like routers that have USB ports on them. This is a VEX Pro controller. I've used them all. Their characteristics are they're low cost, physically small. They run Linux, which says a lot about the power of things that you can do with them. Typically an ARM9 controller, typically with 16 megs of flash, 32 megs of RAM. So that says a lot about what you can't do with them. Can't load a full ROS stack and those kinds of things. But the USB enables cameras, USB to serial, which you can hook up to an Arduino for sensors and the like. And they have enough horsepower for reactive control and vision capture. So what we want to do is connect them into ROS. So we have an idea of implementing an Arduino library on them is one approach, and using ROS serial. So I've ported about half of the base Arduino environment to the VEX Pro controller here. And the idea there is that a good bit of the Arduino community code ought to run on these Linux boxes, which gives you a lot of flexibility in terms of wireless socket access and the like. A second approach that we're playing with is this controller is actually based on a previous product called ROS Quirk. And I'm sorry, called a Quirk controller, and there's a module in ROS called ROS Quirk, which we're trying to get working on on the controller. So I've got a URL for the Subversion source for this code, and would welcome comments, considerations, things we should keep in mind for this class of embedded controllers. And I thought I'd bring this in because, so full disclosure here, Vex Robotics is a sponsor of the Dallas Personal Robotics Group, but I brought it in because I thought it might be interesting to you guys because it is aimed at the university and research market. It does give you Linux and has some decent power, I/O going directly onto the board. And I thought that the reason it might be interesting to you guys is it would integrate with sensors that you can buy off the shelf and metal and such as I've done here, which reduces the overhead of getting your EEs and your MEs involved in making your motors and sensors and electronics and all that work. It just plugs together. So that's where we're going, trying to get ROS integrated with this class of embedded Linux controller. Thank you.
Hello everybody, my name is Thomas Röhr, I'm from TUM. I'm not really an expert in this field, but I felt in my work that I would like to have uncertainty reflected in TF. So I didn't announce this widely because it's not really finished. So far you can only sample, but you can already specify uncertainty in rotation and in translation, as well as in time. So our use case is, for example, we are seeing some data in our Kinect and we're not really sure when the frame was taken by the Kinect. And maybe the robot moved while it was doing so. Maybe we have some joints that we're not so sure about. So we'll find this under uncertainty F. I just felt this might be a forum to announce this. If anybody here wants to use this or wants to contribute, would be nice to talk to you guys. I think that's enough. This was like a minute, right? Okay. 40 seconds. 40 seconds, good.
Started 5 minutes over.
Okay, hi, I'm Dirk Thomas. I just want to give you a short information on what's going on for UI tools for ROS. Currently, ROS features some tools you know, ROS RX, ROS Graph, and stuff like that. It's all built on WX widgets, an old technology, not very good maintainable, not cross-platform. And usually you use a lot of tools at the same time. You always set it up again and again. So we want to come up with an architecture for graphic user tools in ROS. So we developed a framework which builds on top of Qt. So it's cross-platform. It's implemented in Python, either PySide or PyQt-based. And it's featuring a plugin architecture, so you can plug in arbitrary plugins providing your own custom user interface stuff. And they can be either written in Python or C++, and you don't have to deal with binding stuff. The framework itself is ROS independent, and the integration to ROS is done by a plugin. And the features of that is you can run plugins multiple instances at the same time. You can provide arbitrary widgets you need for your UI. You can save and restore the state automatically. You have perspectives, like in Eclipse. You can switch between different combinations of plugins, and you can run them in multiple processes in the same processes or even standalone. Just an impression, what we currently have, we got RX Graph ported to that technology. Don't look too detailed on the verbose output on the top. We can reduce or can improve the UI. The advantage of using Qt here is you can hover over the individual nodes. You get highlighting, which is coming in, which is going out. Like we saw the graph before in the presentation from ClearPath. The graph was not very easily visible. With this one, you get much more highlighting. You got the tools you have on the command line, right, like your ROS topic. You can do topic introspection. You can unfold the message. You can easily see and observe what messages are really posted. And you have the opposite. You can have like post arbitrary kinds of messages. You just select the message type, unfold all types, put in formulas to just publish arbitrary messages, and also have plugins arranged beside each other, stack them on top, have them in separate windows, whatever you like. So on the right side, you see 2D plotting as RxPlot provides that previously. And the things to do next on that is we are currently doing some cleanup, want to provide Debian packages in the next couple of weeks. And of course, someone has to write documentation. And the big thing is we need more plugins. We need to improve the current plugins. So if you have UI tools which you need, which you're currently building or building in the future, come and talk to me. maybe it's possible to integrate them into that architecture. Thank you.
Ian Sherman. Sorry, I neglected the on deck one. And your video is just on the next slide.
I'm Ian Sherman. I'm an engineer at Bot & Dolly, which is a small company in San Francisco that's kept a pretty low profile for the last year or two, but we are really excited to start reaching out and meeting people in the robotics community. We are applying 6-axis industrial robots to the film industry. So what you're seeing here is a motion test that we did where we've got a remote head on a large KUKA robot.
Wrapping up a proof of concept using a motion control.
I'm going to mute it, it might be distracting. That
the ambition for me was just trying
is really a motion test, and what we did was we did motion capture of this fight scene beforehand, and then gave the film director tools to pre-visualize the shot he wanted in Maya, and then click a button to export to our KUKA and capture this sort of footage. We did our first feature film last summer. It's called Gravity. We were able to simulate anti-gravity effects in space just using relative motion of robotic control of the camera. We're also interested in co-opting industrial technology for other uses in the creative industry. So puppeting of robots, also projection mapping on moving 3D surfaces. So that's what we're working on at a low level, and I'd love to talk to you guys because we're really excited to find out what sort of similar problems we're working on. We're also looking for talent to join us. But at a higher level, I think there's two interesting concepts here. One is robot hardware as a commodity. So we're really lucky to have the mature platform of the KUKA robot to start working with, and I think projects like ROS Industrial show really great potential for third-party integrators like us. The second would be motion control as a creative medium in itself, in the same way that audio or sculpture might be. So I hope everyone's thinking about how we can use robotic control for the arts. Thanks.
Hi, I'm Garrett Gallagher, and for the last year and a bit, I've been working on the BillyBot project with my co-founder Juan and Jeff. He's up front, he'll be giving a talk later. This has been a lot of fun. I started basically out of a university lab saying, hey, the Connect is really cool, I want to put it on a Create and help people start doing robotics, on a sort of university level with ROS. So we got a huge amount of interest and naively said, all right, well, if we can make a couple, then we should be able to mass produce them, right? So we started doing that, and that it didn't really scale so well. But we did make 30 of them and sold them out to various people. And that had the advantage of a lot of freedom. We could sort of modify the design and do, what we thought people should have and what people were telling us that they wanted. But it's sort of hard to scale like that. And so in February, we went off to China to start doing like mass production of this, trying to get it out cheaper to even more people, but ran into this problem where if you want to do mass production, you need funding, and then you have to sort of sell this to a VC. And then suddenly we're saying, okay, now we're trying to do this application to convince a VC that they should give us funding to do this thing. But really all we wanted to do was make a robot that people could use with the Kinect. So why don't we just sort of make this into an open source community project, which is what we're sort of trying to move towards. So this sort of is where we're at right now, and we're trying to, I'm currently facing this problem of, all right, if I want to make a community project, how do I, instead of just sort of statically saying, here's all the designs, get people to continuously sort of give feedback and maybe even help change the project. And so if we were to operate like open source software, we'd have to be putting out updates. So I'm kind of open to ideas about this, but one idea is kicking around is what if you had sort of like a subscription service? People can buy into getting updates. So, you know, on 1 month you might send out new encoders that you had developed. And that's sort of an idea, but I'm willing to discuss other things with people. Thank you very much.
So, how many people have suffered from poor time synchronization? Yeah. Okay. So this is sort of a diagram of something that I did when I built that robot. If you saw the ROS Java talk, the one that runs with the 3D laser scanner, well, the very cheap 2D laser scanner that tilts. So we found that there are some problems in the basic algorithm for time synchronization on Hokuya lasers. And basically, the problem is that the uptime of the laser, although it increases consistently, it increases at a different rate than the uptime of your host PC. And so in order to actually get good time synchronization, you need to make some sort of estimate of that rate of increase. And you also need to keep this up to date because since you're communicating over USB, there can be all sorts of different lag characteristics depending on when you actually did this. And so that little blue window there sort of illustrates the time at which you request the uptime from the laser, and then it actually, you follow the arrow and it actually gets to the laser, and then the laser returns the uptime, and then it actually gets back to the host PC. And then you can actually do something like they do with NTP, and you can sort of assume that the round trip time or the communication to the laser took about as long as it took to come back. And then you kind of figure out what time it was on your host PC when for the uptime at the laser that the laser returned. And then you can, over time, actually kind of come up with an estimate of how much more quickly the clock on the laser is running than the clock on your host PC. And then the nice thing is because you're creating this model, you can actually compare the time. You can make an estimate of what the time will be on the laser, and then compare that to what you would have guessed, and then get a measurement of actually how far off you are from the laser's time sync or the laser's clock. So with this algorithm, we were actually able to get sub-millisecond time synchronization. And with the with the normal algorithm that we lifted from the standard Hokuya node, it just didn't work, actually. It was really bad on Android. So that's it. Thanks. So you can actually get access to that. It's called remote uptime clock in ROS Java.
Hi, I'm Patrick Mihelich. At Willow, I've worked on the image pipeline, image transport, algorithms for OpenCV, PCL, and the Connect drivers. And when you're working with messages that contain things like images and point clouds, the problem is that they're really big. So if you have a bunch of nodes that are passing these things back and forth, you end up spending a lot of time doing the serialization and shoving data through pipes, and that can turn into a bottleneck. So one solution to that is to use nodelets, which are basically plugins. You load them all up into the same node process, and when they pass data between each other, it's zero copy. You're just passing a pointer around. So for nodes, when you want to load up a bunch of nodes together, use a launch file. So here, let's say you want a node that does debayering, and a node that takes that debayered image and rectifies it. You have a launch file that loads up a couple of nodes, can do remapping and assign parameters and all of that. If you want to do this with nodelets, you do the same kind of thing. You can use a launch file. In this case, you have to add a manager node, which basically advertises some services so that you can tell it, load this nodelet with this configuration. And then each node gets replaced with a nodelet loader, which is a very thin little thing that just calls a service on the manager, telling it what to load up. So there's some more tricks to doing this well, which I'm going to quickly show you. One is that if you want to compose these kinds of files, you should start the manager separately, so you only have one manager and potentially a bunch of launch files that you want to load into the same process. So you can give the launch file an argument for what the name of the manager node is. If you want this to be robust, it's a little bit tricky. One nodelet, if it crashes, brings down the entire process. Okay. So what you do is you do some arguments where basically if the manager fails, it'll respawn itself if you've told it to, and break bonds with all of the nodelet loaders, which will then also stop, respawn, and reload all of the nodelets with hopefully the same configuration. This is from Stereo Image Proc. Basically, you can include launch files. This is including the same launch file for the left and the right cameras. So these things actually compose pretty nicely. And you can also, to debug them, you can launch the manager in GDB. So that's about it.
So we have one more talk.
Hello, my name is Leif Gentoft. I work with Rob Howe at the Biorobotics Lab at Harvard University. This is a project I worked on with Yaroslav Tenzer in the audience here. Those of you who work with robotic grasping know that there's nothing like the Kinect for tactile sensing. Existing tactile sensors tend to be expensive, tend to be rather fragile, they're very hard to build. We've created a tactile sensor based on a MEMS barometer cast underneath rubber that's sensitive down to 5 grams, buy it for $1 from DigiKey, and you can build an array out of them using standard commercial PCB processes. We've released an open source plan on our website that you can access. Still ironing out a couple of details on it, but this will mean that anyone that wants to have cheap, effective tactile sensing, download the plan. You can trim it to size if it matches your application, modify it if you want, commercial, non-commercial applications. And it's strong, hit it with a hammer, put 25 pounds on it, doesn't matter, and delivers cheap, effective tactile sensing at 100 hertz. If you're interested, talk to us tomorrow. We've got a live demo and also cards for the contact information. Thanks.
All right, so it is beer and snacks time. So it's over. It's gonna be outside, right?
Yeah, it's right outside. It might take a few minutes
Yeah.
more to set up.
So they're still setting up, but first we want to thank National Robotics Engineering Center because the beer, the little beer and snacks outside are courtesy of them. So thank you very much, and thank you to all of our ROSCon sponsors, and thanks for an awesome first day of ROSCon.